So now, we will move to our next topic, the rule of airflow aloft. So anybody from the class know what does airflow aloft mean? Yes, airflow aloft refers to the movement of air in the upper level of the Earth's atmosphere. So the term aloft generally refers to higher altitudes above the Earth's surface. So when we say airflow aloft, it is the movement of the air to which the movement is in the higher altitude or above the Earth's surface. Typically above the planetary boundary layer where surface friction has less influence. So this region is often associated with the upper levels of troposphere and extends into the stratosphere. So the airflow aloft plays a vital role in shaping weather and climate patterns. So there are 5 contributions of airflow aloft to the development of the cyclones. The first one is upper level troughs and ridges. So in the upper level troughs and ridges, the upper level of the atmosphere, there are regions of high pressure, the ridges, and low pressure, the troughs. These or the position and movement of these features influence the surface of the weather pattern. An upper level trough, which is a southward dip in the jet stream, is particularly important in cyclone formation. So the upper level troughs and ridges are significant features in the atmospheric circulation, and they play a crucial role in influencing the atmosphere. So the upper level trough is an elongated region of low pressure in the atmosphere. So troughs are associated with a southward dip in the jet stream, and they often bring unsettled weather conditions such as precipitation, clouds, and atmospheric instability. So the upper level trough has effect on weather, such as trough approaches an area, it can lead to the lifting of air, which may result in the formation of clouds and precipitation. Although there is also upper level ridges, it is also an elongated area of high pressure in the atmosphere. So the difference between the upper level trough and the upper level ridges is that the upper level trough is elongated region of the low pressure, and the upper level ridges is the elongated area of high pressure. So ang upper level trough amo ang low pressure, and the upper level ridges siya ang sa high pressure. So the upper level ridges are associated with a northward rise in the jet stream. So, di ba, ang level trough, upper level trough, southward dip siya ng jet stream. So, ang upper level ridges is the northward rise siya ng jet stream. So, upper level ridges often bring stable weather condition with clear skies, lower chances of precipitation, and warmer temperature. So, the effect of level ridges to weather is that under the influence of upper level ridges, the atmosphere tends to be more stable, reducing the likelihood of precipitation. So, in this, the interaction between troughs and ridges are often part of a larger atmospheric wave pattern with alternating regions of low and high pressure. Okay, di ba, ang trough low pressure, ang ridges sa high pressure. So there is an interaction between the two regions, alternating regions. So the interaction between troughs and ridges influence the movement and the development of the weather systems. And the next contribution is the jet stream dynamics. So, jet stream dynamics, the jet stream is a high-speed, narrow air current in the upper atmosphere, usually located near the boundary between the troposphere and the stratosphere. So, the position and strength of the jet stream influence the development and movement of surface cyclones. In the northern hemisphere, the jet stream tends to flow from west to east. So in the jet stream, it is a high altitude, fast-flowing air current in the Earth's atmosphere. So it plays a crucial role in influencing weather pattern and is associated with boundaries between different air masses. So the formation and location of the jet streams are formed along the boundaries between air masses with significant temperature and pressure differences, often occurring in the upper troposphere and lower stratosphere. So, the polar jet streams is typically found at the boundary between cold polar air and warmer air to the south, while the subtropical jet stream is located between the warm tropical air and cooler air to the north. So, the wind speed of jet stream are characterized by high wind speed, often exceeding about 100 miles per hour or it could be 160 kilometers per hour. So the frontal boundaries of jet streams are often associated with the formation of the frontal boundaries, which are dividing lines between air masses with different temperatures and humidity level. So, there are seasonal variations of jet streams. The position and strength of the jet stream can vary seasonally. So, season lang siya. So, in the northern hemisphere, for example, the polar jet stream tends to shift southward in winter and northward in summer. So, magdepende yun sab siya sa season ang position o strength ng jet stream. So, impact on aviation. So, in the air. So, the strong winds associated with the jet stream can significantly affect aviation, both positively and negatively. So, S-bound flights may benefit from tailwinds reducing travel time. So, kuan man siya kay ang tailwind, so makapaspas siya sa iyahang travel, while westbound flights may face headwinds, so maglisod siya pag tagbo, kay magtagbo man sila gawas kung paiban ang iyahang position or ang iyahang formation ng air. So the third contribution is the frontogenesis. So frontogenesis refers to the process by which temperature gradients or fronts strengthen. So the interaction between the warm-cold air masses along a front is key factor in cyclone development. So the upper level trough helps to intensify this temperature contrast, leading to stronger surface front. So the frontogenesis refers to the process of temperature gradients intensify and result in the strengthening of formation. So formation siya ng isa ka front. So ang front is a boundary between the two air masses with different temperature, humidity, and density characteristics. So the frontogenesis occurs when there is an increase in the temperature gradient across the boundary or across the front. So the frontogenesis has two types: the horizontal frontogenesis and the vertical frontogenesis. So when we say horizontal frontogenesis, This occurs when there is a strengthening of the temperature gradient along a horizontal axis, leading to the formation or intensification of a front. This is a common situation where warm air is advancing over cold air or vice versa. It could be the warm air advancing cold air or cold air advancing to the warm air. On the other hand, vertical frontogenesis is the temperature gradient strengthens vertically. Okay, from the word vertical frontogenesis. So, ang iyahang temperature gradient kay vertically strength. So, it is often associated with the development of weather system in the atmosphere. And also, frontogenesis has impact on weather. So, it is associated with dynamic and thermodynamic processes that contribute to the development of precipitation, clouds, and other weather phenomena. So, it plays a crucial role in the formation of various types of fronts, including cold fronts, warm fronts, occluded fronts, each with distinct weather characteristics. And the fourth contribution is the cyclogenesis. So, cyclogenesis is the combination of a strong temperature gradient at the surface and supportive upper level dynamic of a low pressure system at the surface. So, as it is known as cyclogenesis, the upper level trough helps create a favorable environment for the intensification of the surface low pressure system. So, the cyclogenesis, cyclogenesis, it is refers to the development or intensification of a cyclone. So, cyclogenesis, cyclone, which is a large-scale system of winds that rotate around a central low-pressure area. So, it typically begins with the interaction of different air masses with distinct temperature. So, often associated with lifting mechanisms that force air to rise. As air is lifted, it cools and the water vapor it contains may condense to form clouds, contributing to the development of precipitation associated with cyclones. So, in tropical regions, cyclogenesis often occurs over warm ocean water when sea surface temperature are sufficiently high, or typically about 26.5 degrees Celsius or about 80 degrees Fahrenheit. So, once cyclogenesis is complete, the cyclone may go through different stages including the maturity also. And the last one contribution is the cyclical movement. So, as the cyclone intensifies, it is steered by the upper level winds, primarily the jet stream. The cyclone tends to move along the jet stream from west to east, following the upper trough. So, the cyclical movement of weather systems or seasonal patterns. In seasonal changes, actually, Earth experiences cyclical changes in weather pattern due to the axial tilt and orbit the sun. So, this result in the changing seasons. There is a spring, summer, autumn, and winter. So, each season has its own characteristics, weather condition, temperature variation, and also daylight hours. On the other hand, in the monsoons, in the cyclical movement, makabase siya sa seasonal changes and monsoon. Kaya ang monsoon, may kuan man sab niya. Like in certain region, there are cyclical movement associated also with the monsoons. It involves also the seasonal shifts in winds pattern, bringing wet and dry period mo na tag-ulan at tag-tuyo. Tuyo? Tag-tuyot. Something. Basta the dry and the wet season or period. So, for example, sa mga Indian subcontinent, they experience a southwest monsoon during summer and northeast monsoon during the winter. So, that's all in the rule of the airflow aloft.